Number 17, given that these two lines are parallel, you're supposed to prove that this angle plus this angle would equal 180. Okay, so the first thing we need to do is we need to talk about, like, I think I'm going to name this angle 4 just because it's going to give me a little more to talk about. So you want to prove it. So we got some proofs. You always start with what's given. H is parallel to K. That's given. Okay, if H is parallel to K, then I actually know that angle 1 and angle 4 are congruent, right? Angle 1 is congruent to angle 4 because they're corresponding angles. And now I also know that angle 4 and angle 3 make a linear pair. So that means since they make a linear pair, measure of angle 3 plus measure of angle 4 equals 180 by the linear pair postulate, right? So now, I think I would have preferred maybe to write measure of angle 1 equals measure of angle 4 so we can do this. So now look, I can take this measure of angle 4 and substitute in measure of angle 1. Measure of angle 3 plus measure of angle 1 equals 180 degrees. That's just by simple substitution. And now I've proven what I wanted to prove. 18 is a proof as well, but this is a proof involving similar triangles. They're giving you some things and they want you to prove that these two triangles are similar. So, again, we're starting with what's given. We know that AB over DC equals AC over CE. So we know that this side and this side are in the same proportion as this side and this side, right? That's given. We're also given that AB is parallel to segment CD. That's given. And anytime you have parallel lines cut by a transversal, you can make some conclusions about the angles, right? This angle is going to correspond to this angle because that's the parallel line they're cut by this transversal. So measure of angle A is equal to measure of angle C because they're corresponding angles. Well, at this point, you have side, angle, side, side, angle, side. So we can say that these two triangles are similar by side, angle, side. So we have proven the similarity. Now, for the final proof, we're going to be using, we know that this is a parallelogram. We want to prove that these triangles are congruent. So we know PQRS is a parallelogram. That's given. So now we just need to use that definition. That means that PQ is parallel to RS. So PQ is parallel to RS. That's by definition of a parallelogram, right? Okay, and we also, so the minute we know that, we can say that this angle is congruent to this angle by alternate interior angles because they're cut by that transversal. So angle QPS is congruent to angle RSP because they're alternate interior, right? We also know that segment PS is congruent to itself because segments are congruent to themselves. Okay, so we've got one angle, we've got one side, and we know that it's congruent. Now, if we just had something else, like maybe the side or maybe another angle, we would be able to say this. And the thing is that parallelograms don't just have one parallel side, they have two parallel sides, right? So we know that PR, segment PR, is parallel to segment QS. Again, that's definition of a parallelogram. And because these two are parallel, we also know that this angle is congruent to that angle. They're also alternate interior, right? So angle QSP is congruent to angle RPS by alternate interior. And at this point, we have angle, angle plus a scale factor of 1. So we can say triangle RPS is congruent to triangle QSP by angle plus scale factor of 1, right?